Hello students, this is Harish Kumar. Welcome to my channel, the Chemistry Classroom. Today we are going to discuss the General Organic Chemistry Part 2. In this part, we are discussing about the isomerism. So what is isomerism? With examples we discuss. So before starting the class, I request you all, please see the video up to the end and promote my channel also. Okay? Right. So now we are discussing about the isomerism. It is one phenomena in organic compounds. So what is this phenomena? How we identify that one? Now we see. The topic it is called isomerism. So in this one topic, so how we are discussing now, see. In the organic compounds, generally they have the same molecular formula. The molecular formula is same, but they differ in the structure or they differ in the spatial arrangement. So what they are differ? They differ in the structure or they differ in the spatial arrangement. By that we are getting two or more compounds. The compounds are having same molecular formula. The formula is same, but they differ in the structure or they differ in the spatial arrangement. Like the top compounds, they are called isomers. That phenomena is called isomerism. So how they differ? Now one by one discuss. So the first one is they differ in the structure or they differ in the spatial arrangement. So the spatial arrangement is in two types. The one is geometrical and the second one is optical. So how they one by one we discuss. So here the structure, based on the structure, they differ in the structure. They are having the same molecular formula, but they differ in the structure. So how they differ in the structure? Now one by one we see. The structure is in four types. The one is called chain isomerism. The second is called position isomerism. And the third is called functional group isomerism. And the fourth one is called metamerism. So the four all belongs to the structural isomerism. In this, the molecular formula is same, but they differ in the structure. The one is chain isomerism, the second is position isomerism, and the third is functional group isomerism, and the fourth one is metamerism. One by one we discuss. So here you see, the first one we discuss one by one. The structural isomerism we are discussing. In the structural isomerism, the first one it is structural isomerism. Here the molecular formula is same for that compound. The two compounds are having same molecular formula, but they differ in the structure of the molecule. So the first one is structural isomerism. In the first one it is chain isomerism. So how they differ? Now one by one we see. So for example, I have one compound C4H8. What is the compound? It is C4H8. The compound is butane compound. Now we see the structure. The structure in this compound, the four carbons completely they are attached to each other. The chain we written here, and the remaining they are hydrogen. The first carbon is having 3 hydrogens, and the second carbon is having 2 hydrogens, and the third carbon is having 2 hydrogens, and the fourth carbon is having 3 hydrogens. Like the structure we made. So in this structure, so how many carbons we have? 4 carbons. So the 4 carbons belongs to the compound, it is butane. So the carbons are straight chain. So it is called N-butane, normal butane. Already in the nomenclature we discussed. So here the compound C4H8. In this C4H8 the compound is butane compound. The molecular formula for this compound is C4H8. Now again I will write one more compound. Now you see this compound. So this carbon is having 3 hydrogens. This carbon is having 1 hydrogen, and this carbon is having 3 hydrogens, and this carbon is sorry, C4H10. This carbon is having 3 hydrogens. Now this compound, now we see, so the straight chain we observed, the compound is belongs to propane. In this propane, one side chain we are getting. What is the side chain? It is methyl. What is the side chain? It is methyl. So this compound is called methyl propane. In this methyl propane, if we count, what is the carbons here? C4. So how many hydrogens here? H10. The 10 hydrogens only have. In the first compound, N-butane, we have C4H10 is the molecular formula. For the second compound also, the molecular formula is C4H10 only. Here the molecular formula is same, but they differ in the structure. How they are different? Here that in the first compound they don't have the side chains. In the second compound we have the chain. So here the two compounds are differ in the chain. Here in the first compound we don't have any side chain. Here we have one side chain. So they differ in the chain. So they differ in the branches. So that's why this isomerism is called chain isomerism. Here the two compounds are having same molecular formula, but they differ in the chain. So they are called chain isomerism. So one more this compound we discuss. So I am writing one more compound. Here you see the 5 carbons we have. The first carbon 3 hydrogens, 2 hydrogens, 2 hydrogens and 3 hydrogens. So here in the compound, so we have 5 hydrogens and 5 carbons and 12 hydrogens, C5H12. So this formula, that compound is belongs to N-pentane. This compound is belongs to N-pentane. Here the 5 carbons are in the straight chain, so we don't have any branches. This compound is called N-pentane. The molecular formula for this compound is C5H12. So what happened here, you see, I made one branch. For example, one carbon I eliminated and made a branch. So here you see, this compound when you observe, here we have one branch. The two compounds are different in the branch. Now you see, here also, what is the name of this compound? It is methyl substitute. We have methyl side chain. We have the compound is butane. So it is the butane compound. And this butane compound, what we have? The methyl group we have. It is called methyl butane. At the second position, we have the methyl. So 2-methyl butane compound. Here the compound is N-pentane. Here the compound is 2-methyl butane. So here also we have 5 carbons only. And the hydrogens also the 12 only. It is C5H12 only. The two compounds are having same molecular formula, but they differ in the chain. So that's why they are called chain isomerism. So one thing you have to observe, in the chain isomerism, the molecular formula same. They differ in the name also. IUPAC name you will get. The different IUPAC names you will get. So for example, one more compound you see. So here also you are getting 5 carbons only. So how many hydrogens you are getting? The same one, that is 12 hydrogens. The carbons are 5 and hydrogens are 12. So what is this compound? It is 2,2 dimethyl propane. What is the compound? It is 2,2 dimethyl propane. In the first compound we don't have the chain. In the second compound we have one chain. In the third compound we have 2 chains. So they differ in the chain. That's why they are called chain isomers. So how you identify? In the chain isomerism, the compounds, the molecular formula same, and you will get different nomenclature also. The names also different. So automatically they are belongs to the chain isomerism. It is your first isomerism. Now we discuss the second isomerism, that is called position isomerism. What it is called? Position isomerism. Now one by one we discuss the position isomerism. I am discussing. The second one, it is position isomerism. So the molecular formula same again there. So what they differ, now we see with example I will see. So one compound I am writing, this compound, what is the name of this compound we see. In the second carbon we have the chlorine, so it is 2-chloro. The compound is belongs to haloalkane. The halogen is the chlorine, so it is 2-chloro. So how many carbons you have? 5 carbons. The compound is pentane compound. Here 2-chloropentane compound. So how many carbons here you have? That is 5 carbons you have. And hydrogens is 11 hydrogens. Why? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1 chlorine is there. The molecular formula of the compound is C5H11Cl. So one more compound I am writing now. You see the same pentane compound. So here I am writing 1 chlorine. So here the 5 carbons only we have. That is C5 only. The chlorine, it is in the third position. 1, 2, 3 and 4 and 5. So in the third position we have the chlorine. So the compound name is 3-chloro and it is 5 carbons we have. So it is pentane compound. So what is the name of the compound? 3-chloropentane. In this compound, how many hydrogens we have? You see 3, then 2, 5, 6, 7, 8, 9, 10, 11. So 11 hydrogens you have and 1 chlorine. The molecular formula for these two compounds are same. That is C5H11Cl, C5H11Cl. But what they differ? In the first compound we have at second position the chloro group is there. In the third carbon the chloro group is there. What they differ? They differ in the position of the chain. The position of the group or position of the chain is different. So here the second position is having the chlorine and here the third position is having the chlorine. So automatically they are belongs to the position isomerism. They are having the same molecular formula, but what they differ? They differ in the position of the chain. So it is 2-chloropropane, 2-chloropentane. This one is 3-chloropentane. They differ in the position. Now you see, so generally in position isomerism, you will get the same parent chain. Here it is the pentane compound, it is also the pentane compound. But they differ in the position only. It is the second position, it is the third position. In the two compounds, they are chloropentane only. But it is 2-chloropentane, this is 3-chloropentane. So what you remember, in the position isomerism, you will get the same molecular formula and the maximum, the main parent chain is same. It is the pentane chain, it is also pentane chain. The position also, that is chain also here chlorine, here also chlorine, but the position it is 2 and the position is 3. This isomerism is called position isomerism. They are having the same molecular formula, but they differ in the position of the chain. Such type of isomerism is called position isomerism. It is our second isomerism. And the third one we discuss, that is called functional group isomerism. So what is functional group isomerism? Now one by one we discuss. So what is the third one? It is functional group isomerism. So in this isomerism, the molecular formula is same, but they differ in the functional group. So how they differ? They differ in the functional group. For that I am giving one example. So this compound now you see. So I am writing the IUPAC name of the compound. Here it is the functional group, it is OH. The oxygen is the heteroatom and it is in the form of OH. So the compounds are belongs to alcohol compounds. What are the compounds? They are alcohol compounds. For the root word it is alkanol. What is the root word for this compound? Alkanol. Now already in the previous video we discussed about the root words. So what is the root word here? Alkanol is the root word. So here alk indicates the number of carbons. So how many carbons you have? 2 carbons. So it is eth. The compound is called ethanol compound. What is the name of the compound? It is ethanol. So here the OH is the functional group. That's why they are alcohols. So how many carbons here you have? 2 carbons here you have. So how many hydrogens you have? 6 hydrogens and 1 oxygen. So what is the molecular formula for this compound? C2H6O. So what is the compound? It is ethanol compound. So in this compound, what is your functional group? That is alcohol is the functional group. I write one more compound. Now you see this compound. In this compound, oxygen is the heteroatom. It is in the form of O. It is in the form of OH, so they are alcohols. It is in the form of O, so they are called ethers. What they are called? They are called ethers. So in this ethers, so one carbon is attached to the oxygen, another carbon also attached to the oxygen. Here oxygen attached with the two-sided carbons. So this functional group is called ethers. So the root word it is alkoxyalkane. What it is? Alkoxyalkane. What is the root word? Alkoxyalkane. So it is methoxy. This one is methanol. So the compound is methoxymethane. What is the compound? Methoxymethane. In this compound, how many carbons you have? 2 carbons only. Hydrogens we count the 3 and 3. The 6 hydrogens we have and 1 oxygen. C2H6O. In these 2 compounds, we have same molecular formula. C2H6O and C2H6O. But what they differ? They differ in the functional group. In the first compound, the functional group is alcohol. In the second compound, the functional group is ether. So, their molecular formula is same, but they differ in the functional group. That's why they are called functional group isomerism. So, one more example we give. So, for example, I am writing one compound. So this compound if you observe, so what is your function group? That is aldehyde is the function group. So the compounds are belongs to aldehydes. So generally the root word is alkanol. What is the root word? It is alkanol. So alk equal to how many carbons you have? 3 carbons. So it is prop. So the compound is propanol. What is the compound? It is propanol. In this propanol, how many carbons you have? 3 carbons you have. And the 3 hydrogen 2 plus 5 plus 1 that is 6 hydrogens and 1 oxygen C3H6O. That is the molecular formula for this compound. This compound is aldehyde compound. So what is the name of that compound is propanol. With the same 3 carbons I am writing one more compound. Now you see. So in this compound the C double bond O is the function group. Here the CHO is the function group. Here the function group is C double bond O. So the compounds are ketone compounds. What they are called? Ketone compounds. So what is the root word? It is alkanone. What is the root word? It is alkanone. Alk equal to here how many carbons you have? 3 carbons. So it is pro. So it is propanone. The compound is propanone. In this compound how many carbons you have? 3 carbons. So how many hydrogens you have? 6 hydrogens. And how many oxygens you have? Only 1 oxygen. That is C3H6O. So here the molecular formula is same, but they differ in the functional group. Here the aldehyde and here it is a ketone. The functional group is different. So they are belongs to the functional group isomerism. Molecular formula same, but they differ in the functional group. That's why they are functional group isomerism. So one more example we'll see. So I am writing one more example. So when you see this compound, it is COOH is the functional group. What is the functional group? It is COOH. So the compounds are belongs to carboxylic acids. The compounds are carboxylic acids. So what is the root word? It is alkanoic acid. The root word is alkanoic acid. So here alk equal to be substitute. How many carbons you have? 3 carbons. So the compound is propanoic acid. What is the compound? It is propanoic acid. So how many carbons you have here? The 3 carbons you have and the hydrogens 3 plus 2 5 plus 1 it is 6 hydrogens and oxygens you have 2. It is the formula C3H6O2. So the compound is carboxylic acid. The root word is alkanoic acid. So what is the compound? It is propanoic acid. One more compound I am writing now you see. So when you observe this compound, so what is the functional group? It is COO is the functional group. COO functional group, the compounds are called ester compounds. What they are called? Ester compounds. So it is methyl methanoate, the compound. So what is the root word? Alkyl alkanoate. Alkyl alkanoate. So one is methyl and it is methanoate. The compound is methyl methanoate. The compound belongs to the ester. So how many carbons here we have? 3 carbons only. So how many hydrogens we have? 3 plus 3, 6 hydrogens. So how many oxygens we have? 2 oxygens. The molecular formula of this compound also C3H6O2. The first compound C3H6O2 and the second compound also C3H6O2. The two compounds are having same molecular formula but they differ in the functional group. That's why they are called functional group isomerism. So here the alcohols and ethers, aldehydes and ketones and acids and esters, they are belongs to the functional group isomerism. So these compounds when you have, so automatically what they do, they are in functional group isomerism. That is your third isomerism. Now we discuss the fourth one, that is metamerism. What is the metamerism? The fourth one, it is metamerism. To perform the metamerism, isomerism, compulsory we need some groups, some functional groups which is having two sides carbons. For example, the ether compounds you have, in these compounds the carbon is having two-side chain. So both side if you have the chain, that compounds only performs the metamerism. Compulsory you should, the two sides compulsory, we have the carbon chain, then only it performs the metamerism. Now we see I writing one compound. So this is the compound, ether compound. In this compound you observe, so one is alkoxy, the root word is alkoxy, alkane. So what you have? One is alkoxy, other one is alkane. So what is alkoxy? It is ethoxy. The compound is ethoxy. And what is the compound? It is ethane compound. The compound ethoxyethane. In that compound, how many carbons you have? 4 carbons. Hydrogens, how many you have? 10 hydrogens and 1 oxygen. C4H10O. So I write one more compound here. This compound also ether compound only. So here one side methyl group we have, one side propyl group we have. So it is called methoxy. The compound is methoxypropane. What is the compound? It is methoxypropane. In this compound, how many carbons you have? 4 carbons. So how many hydrogens you have? Same 10 hydrogens only. How many oxygens you have? Only 1 oxygen. C4H10O. The two compounds are having same molecular formula. But what they differ now, you see, the functional group is having both sides the chain. In the first compound, the both sides you have 2 carbons. In the second compound, so one side you have 1 carbon and the other side you have 3 carbons. What they differ? They differ in the side chains of the functional group. What they differ? They differ in the side chains of the functional group. This type of phenomena is called metamerism. Similarly for ketone compounds and for ester compounds also you will get the metamerism. Why? Because for the ketone compounds, the both side you have the carbon chain, and for the ester compound also, both side you have the carbon chains, which is having both side carbon chains for the functional group, that will perform the metamerism. That is one fourth one. These 4 are called structural isomerism. Why? Because they differ in the structure only. The chain position, the chain we differ, the position of the chain we differ, in the functional group we differ, they differ in the side chains of the functional group. So they are called structural isomerism. That is our first isomerism. And second one, it is called spatial arrangement. So how they spatially arranged, based on that you are getting some isomerism. In that first one is called geometrical isomerism. What is the word one? Geometrical isomerism. So to perform the geometrical isomerism, what is the first condition? A double bond. So where it is a double bond compounds only performs this geometrical isomerism. Compulsory the carbon and carbon will undergo in the double bond or whatever the compounds. If you have the double bond, it will perform the geometrical isomerism. Why? Because when the double bond is between the carbon atoms, so the rotation is restricted. What guy? The rotation is restricted. So automatically you are getting the spatial arrangements. They differ in the spatial arrangement. So they are called geometrical isomerism. If the carbon and carbon is having single bond, so automatically we can easily rotate. So for example, you see the carbon is having like this single bond, so easily we can rotate. by easily we can rotate, we are getting so many structures. They are called conformations. What they are called? They are called conformations, and conformations. So you are getting the structures. They are called conformations. They are the different isomerism. So if you have double bond between the carbon atoms, so what happened? You see, for example, you see this one. The two bonds are in between the carbon atoms. So when the two bonds are formed, so you are not able to rotate. The restricted rotation. What it is called? Restricted rotation. Because of the restricted rotation, you are getting the different structures. So this type of structural isomerism is, sorry, this type of spatial arrangement is called geometrical isomerism. For example, you see here, so one hydrogen and this one is hydrogen. So for example, one side hydrogen and one side the. So I am writing this compound. So when you see this compound, so what happened? You see the carbon like this. The groups are arranged, the remaining groups are arranged. Here the rotation is restricted. So I am writing one more compound. Now you see. The both are having the same molecular formula. The molecular formula is same and the IUPAC name also same. So what is this compound? 1 bromo 2 chloroethene. The compound is 1 bromo 2 chloroethene compound. This is also 1 bromo 2 chloroethene, but they differ in the spatial arrangement. Why? Because here you see, you observe the methyl and the chlorine group in the same side. Here the bromine and chlorine group in the same side. Here bromine and chlorine group is in the opposite side. So they are having the same side, they are having the opposite side. If we have the same side, this compound is called cis compound. If they have opposite side, this compound is called trans side. So how they differ? They differ in the geometrically. The spatial arrangement, geometrically they are differ. That's why they are called geometrical isomerism. One more example we can take. The compound is called 2-butene compound. Here you see, the compound is 2-butene. 1, 2, 3, 4. In the second position you have a double bond. This compound is 2-butene compound. What is the compound? It is 2-butene compound. One more I am writing here, you see. So this compound also 2-butene only. Here the IUPAC name also same. The molecular formula same and the IUPAC name same, but they are differ. They differ in geometrical isomerism. They differ in the geometry. Why? Because in this geometry the methyl groups are in the same side. In this geometry the methyl groups are in the opposite side. If the methyl groups are in the same side, this compound is called cis 2-butene. If the methyl groups are in the opposite side, they are called trans 2-butene. So like this we mention the geometrical isomerism. The spatial arrangement is different, so they are called geometrical isomerism. And lastly, we discuss about the optical isomerism. So what is optical isomerism? You know very well. So now we discuss about the optical isomerism. Before learning about the optical isomerism, we have to know about the polar light. What is called polar light? So here you see the polar light. So from the source, the light is traveled, the light is released. The waves of the light is spread over all over like this. So this light is called polar light. So when this light traveled from some source or this compound, so automatically the light is rotated in one direction, either in the clockwise or in the anti-clockwise. The total rays are rotated in the clockwise like this, or the total rays are rotated in the anti-clockwise. So it is called plane polarized light. The plane polarized light, the lights will spread over around this. So, but the light is totally diverted into one side, the rotated into one side, either the clockwise side or anti-clockwise side. If the clockwise side, the plane rotation, the light is rotated, this is called dextro rotation. If it is anti-clockwise, that is Leo rotation. If the compound is optically active, it will rotate the plane polarized light in one direction, either in the clockwise direction or in the anti-clockwise direction. If it is in the clockwise direction, the compound is dextro compound. If it is anti-clockwise direction, the compound is Leo compound. So when the compound is getting the plane polarized light is rotated, so we have one condition, the carbon should be chiral. The carbon should be chiral or asymmetric carbon, which is having four different molecules or atoms or groups. That carbon is called chiral carbon. For example, one hydrogen, so one is chlorine, one is bromine and one is iodine, for example. The carbon is having four different groups. So this type of carbon is called chiral carbon. The chiral carbon, if you have asymmetric carbon or chiral carbon, then only it rotates the plane polarized light. So if you have one chiral center or chiral carbon, then only it rotates the light plane polarized rays. So when it is chiral, so you will get the optical. So you will get a mirror image for this compound. So you see this one. So here the chiral carbon here. So you are getting the mirror image. The two are having the mirror image. So because of the mirror image, these two compounds are identical, but they are not going to overlap each other. They are not going to overlap each other. So they are mirror images only. They are not overlapping each other. So this type of compounds are called optical isomerisms. The compound, if the light is rotated dextrally, other compound will rotate the light in Leo. That is, one is rotated the light in clockwise, the another compound will rotate in the light, that is anti-clockwise. So one is called dextro compound and another one is called Leo compound. So one more example will take. The compound is called glyceraldehyde. What is the compound? It is glyceraldehyde. So in the glyceraldehyde compound, this carbon is the chiral carbon. You are getting the mirror image for this compound. So this compound is glyceraldehyde. So we are getting two compounds. So one will rotate the light in the clockwise, another will rotate in the light in the anti-clockwise. One compound we call dextro and another compound we call Leo. So which is having the right side OH group, that will rotate the light in the clockwise. That compound is called dextro. If the OH group in the left side, the compound will rotate the light in the anti-clockwise. That compound is called Leo compound. Like that, the isomerism we discussed. So here generally we have two type of isomerisms, structural isomerism and arrangement in the spatial. You are getting the two type of arrangements. The one is geometrical and the second is optical. So they are isomerisms. So next part, the chemical reactions, the reactivity of the chemical compounds we discuss in the part 3, right?